All right, here we have our sixth type, which is going to be two different videos. The type is going to be exponential for each video. And in this one, we're going to focus on what we call exponential growth. So that's going to be this one over here. This is exponential growth. Now, there is no parent function for exponential growth. Basically, if you have, y equals some number to the power of x, if that number is bigger than 1, that is going to be exponential growth. So in our case, we have y equals 2 to the x. That is an example of exponential growth. You could think of that as a parent function, but it could be 3 to the x or 4 to the x or anything like that. So again, if I plugged in negative 1 for x, that would be 2 to the power of negative 1, which is the same thing as 1 over 2. Remember, if it's a negative exponent, we move that base into the denominator. So that's going to give us 1/2. This one over here, if I did 2 to the power of 0, 2 to the power of 0, if we remember anything to the 0 power is equal to 1, so that one's going to be 1. And 2 to the power of 1 is just 2, right? So if I wanted to graph these, I would start here with this xy, so I have negative 1, 1/2. Then I have 0, 1, and then I have 1, comma 2. I could keep going, but I'm going to get a graph that follows those lines and then goes up pretty steadily like that. So that's what we call exponential growth. So what I want you guys to do is find the domain and range of it. Now keep in mind, we've talked about this a little bit in class. It doesn't matter what you plug in for x, you cannot get anything down here. This is what we call an asymptote, that dotted line.